Cord. Thank you. Okay, so this one, it's been a little bit, right, since we've done these. You with me, gentlemen? Yes. Okay. Make sure you know the difference. This first one is standard form. The next one is vertex form. This is where one of the errors was made. There's supposed to be a squared down there, and it wasn't there. Sorry if that threw you off. So with this, how do you find an axis of symmetry? What's the formula? Because you need to know this. I don't give this to you. Oh, I do give you the quadratic formula on your final, by the way. So you don't need to memorize that one, but you need to know all those other formulas that are on that sheet of paper, okay? Yeah, go for it.
Is it S equals negative B divided by 2 times A?
Negative B over 2A. Remember that? Hopefully. So a negative B right now is a positive 4 over 2 times 1. So you get 4 over 2 is 2. So your axis of symmetry, don't do this wrong, is X equals 2. Okay? So you go right here, X equals 2, and draw that line in. Okay, how do you find your vertex then? What's your X value of your vertex? 2. It's your axis of symmetry. So we're going to plug in a 2, and then we just plug it into the formula. 2 squared minus 4 times 2 minus 3. So this is 4 minus 8 minus 3 is negative 4 minus 3, which is negative 7. So 2, 1, 2, 3, 4, 5, 6, 7. Okay, so there's your vertex. How do you find the y-intercept in this standard form? You can always plug in 0, right? For both forms, you can plug in 0. There's a quicker way on this one. It's always this C term. But either way, if you plug in 0 or if you look at your C term, you get negative 3. So 0, negative 3, 1, 2, 3, and then reflect that. Okay, now technically that's all I need from you, but if you would like to give me the point in between those, how do you do that? Do you remember? What's out here? In front of your x squared. A 1, right? You can do one slope, up 1 to the left 1, up 1 to the right 1. So your graph will look like that. Okay? What is your minimum? Your lowest point, y value? Negative 7. All real numbers is your domain because we can plug anything in for x. And what's your range? Greater than or equal to or less than or equal to? Greater than or equal to because it's on its way up. Negative 7. Hey, Jaden. You should turn this way and pay attention. It'll be helpful, I promise. Other questions?
Oh.
Yeah.
Number 7 on page 10.
Ooh, too far. Okay, so number 7 looks like this. What's the first thing you do if you're going to factor this? Yeah, take out the GCF. So divide everything by 2. You get 9x squared minus 4. What do you notice about those two things? Perfect squares, right? So this is a difference of perfect squares. A difference of squares is the one where you do a binomial plus and a binomial minus, and you just take the square root of both. So the square root of 9x squared is 3x. That goes in the front. The square root of 4 is 2, and that is your answer. Okay? Other questions? Yeah, Miles.
Can you do number 16 on page
12? Find the zeros and state their multiplicity. So this is just saying, how do I make this equal to 0? What's that going to be? That's 0, right? With a multiplicity of what? A multiplicity of 2. Your exponent is your multiplicity. So x equals 0 multiplicity 2. What's your 0 here? How do you make x plus 2 a 0? Jackson, this is what you were asking me about. Does that make sense to you now? -2. So this is -2 with a multiplicity of 3. And then how do you make this a 0? Just -1, right? And you don't need to write multiplicity of 1. There's no multiplicity there. It's just one time. So this would be your answer. Next one.
So
Yeah.
basically you're just taking every x and just
Making it a 0.
Okay.
Like how do you make each binomial or term a 0?
Okay.
Yeah. Real quick, because I'm looking at it and we changed some things on the final this year. In a problem like this, first of all, how many solutions do you have on number 26? 4 solutions. Okay. Tell me the options for those 4 solutions. Do you remember? We talked about it in class. We did it in the notes. You could have 4 real solutions. Ooh, that's an N. Solutions. You could have 4 what? Imaginary or complex solutions. Okay, is there any other combination? Can you have 3 in 1? No, because an imaginary always has its conjugate, right? So what's the only other option? 2 real and 2 imaginary. Okay, so when you have a 4th degree, those are your only 3 options for how many solutions or what your solutions could be. Okay? Yeah. 2 on page 11. What page are we on here? This, which number 2? The graph or this one? Okay. Number 2 says, what system describes this graph? So here's what you're looking at. First of all, there was supposed to be shading here and it didn't show up very well. This is shaded. Okay. Which means you have this line as a barrier, this line as a barrier, and this line as a barrier. So that maybe would clear things up for you a bit. Notice your lines, okay? Because the first thing you should be able to pick out is there are dotted lines and there are solid lines. So if there are both, this is not even an option because those would all be solid lines, right? So you can kind of eliminate things as you go. This would not be an option because those would all be dotted lines and they're not all dotted lines, right? So right off the bat, you can get rid of those ones. Then if you look at this, let's see, I would probably, well here, let's just do this. Do you know what the line y equals x is? Think of points, 0, 0, 1, 1, 2, 2, 3, 3 would make that true, right? So all of these points here, 0, 0, 1, 1, 2, 2, 3, 3. Y equals x is a solid line there. That's a dotted line, so that can't work. So it ends up, it has to be this. Another way you could check it, it says x is greater than or equal to -2. So here's x equals -2. If it's greater than or equal to that, you shade to the right of that, which is where our answer is shaded. So that's just another signifier that that's the right one. But basically, it's kind of a process of elimination thing. Like, I know it can't be this. I know it can't be that. If you wanted to, you could just graph it on your own, but then you'd have to graph so many different problems. I say elimination is a simpler way to get there. Yeah, Amara.
15 on page 12.
This 15? So you need this to be a 0 and you need this to be a 0. So basically we're saying 3x minus 2 equals 0 and x plus 4 equals 0. So if you add 2, you get 3x equals 2 and then divide by 3. So you get x equals 2/3 with a multiplicity of what? 5, right? That exponent. So 2/3 5 times. And this one, take away the 4, x equals -4 with a multiplicity of 2 because of that. So that's an answer. and that's an answer. So you're just setting them equal to 0 and solving it, each piece. And then your multiplicity comes from the exponent. That make sense?
Wait, so you know how it says x plus 4, so you just change it to anything?
Yeah, because we want this whole thing to equal 0. Well, in order for this to equal 0, the x value right here has to be -4. -4 plus 4 is 0. So we're looking for what could you plug in right here that will make it a 0. So if I plug in 3 times 2/3 minus 2, it equals 0. So that's why we say you just take what's in the parentheses and set it equal to 0 and then solve. Okay, Jenna. Page 12, 27. Okay, this says what is p of -5 if p of x is that? You're not missing any of your exponents, so you can just set it up right off the bat how you see it. -1, -4, 1, and -2. P of -5 means you just put that -5 right there. And now your answer is whatever's in that box. Your remainder is your answer. So what you're going to do is bring down the -1. Some of you did this very wrong on the test, by the way, so make sure you're paying attention and this is making sense to you. And if it's not, ask me. So whatever P of is, you're going to put right here. Drop down your first number below the line. Some of you just dropped it right here and then did some weird things with adding and subtracting. Now you go -5 times -1 is a +5. Do you add or subtract in synthetic division? You add. Okay, so now I'm going to go -4 plus 5 is 1. Now we multiply. -5 times 1 is a -5. Add again. 1 plus a -5 is -4. Now we multiply. -5 times -4 is a +20. And now you add them again. -2 plus 20 is 18. So P of -5 is 18. Do you know how you can check your answer? Plug it in. Put a -5 in here and see if you get 18 for that. If you do, you're good.
Could we just plug in -5 to the equation?
On the final, it would say, or like on the test, it said use synthetic division.
Oh, okay.
So you have to plug it into synthetic division.
Okay.
Yeah. Yeah, this one didn't specify. Did it up here? No. Yeah, but in the future. Oh, I should have put it right below this one. Yes,
Is this
Amar.
one above 27?
This number 20 right here?
Yes.
So you have, what does it say? Solve by factoring. So we're going to factor this. Is there anything you can factor out? Do you have a GCF? X, right? So factor out an x. You're left with x squared plus 3x minus 54. Okay. What do you do next? Star method, yeah. So this is going to be what can I multiply to get a -54 that I can add to get 3. My A term is 1 and 1. What does that come out to? 6 and 9. Which one's negative? The 6 is going to be your negative. So you have an x out in front. Don't forget him. And then x plus 9 from this one. And then x minus 6 equals 0. Something that some of you did on the test was you forgot to solve it. So you factored it. You got to here. But then you didn't solve it. Solving means I want to know what does x equal. So what you do is x equals 0 for that one. What about for this one? -9 and +6. Okay? Yeah, Chloe.
Do 19 on that page?
Yes. So 19, this one again, solved by factoring. So this one we're gonna leave as is. This one we're gonna do star method for. So what can you multiply to get a negative 40 that you can add to get 3, and your A term is 1? What do? 8 and negative 5, right? So this is x plus 2, x plus 8, and x minus 5 set equal to 0. So when you solve it, what are your x values? For this one, negative 2. For this one, negative 8 and 5. Clara, what was your question?
I was gonna ask the same thing.
Okay. Other ones?
Could you do 21 on page 13?
Page am I on? 21. This one, synthetic?
Yes.
Okay, so for synthetic division, you do everything backwards, right? So flip the bars upside down. This is 1, negative 4, 1, and negative 5. Here's your remainder. With synthetic division, what goes out in front? A negative 2, opposite of what it looks like, right? So a negative 2 here. Ditch the x. It's long division that the x sticks around. Synthetic division, we get rid of it. So drop down your 1. Negative 2 times 1 is negative 2. And now we're adding these. So negative 4 plus negative 2 is negative 6. Now multiply. Negative 2 times negative 6 is a positive 12. Drop that down. 1 plus 12 is 13. Multiply that. Negative 2 times 13 is a negative 26. Add those together. You get a negative 31. And now you set it up as your polynomial. So this is your remainder. This is your constant. This is your linear term. So there's just an x attached to that one. And this is your quadratic term. So 1x squared. So this would be your answer. Yeah.
Can you put the number 6 on page 13?
Okay, so which of these quadratic equations has the factors of x minus 2 and x minus 3? There's a couple ways you could do this. You could factor each one of these and see what they come out to. What's the quicker way to do it?
We factor the x minus 2.
Not factor it, but what's the other word? 4-letter F word? That's not a bad word? Foil it, yes. X minus 2 and x minus 3. If you just FOIL that, it will get you your polynomial. So x squared minus 3x minus 2x is minus 5x. And then negative 3 times negative 2 is a positive 6. So you just have to find that one in the mix, which is right there. Okay? Yeah.
I did it differently, like I did like star method, and then I put like the negative 2, negative 3, and then I like added and then multiplied them to get to the number.
Oh, yeah. That's fine. Yeah, you did the same thing. It's just probably more work the way you did it.
This was faster though.
Oh, that's great. Yeah, if that's better for you, do it that way. Totally fine. Molly?
Back to number 15 on page 12, when would be the case when we add the exponents requiring multiplicity?
15.
Remember we did one where we had to add the exponents?
If they're identical.
Okay.
If it was like x plus 4 with a multiplicity of 2 and x plus 4 to the third power, then that's a negative 4 to the fifth power, right? Because it's the same thing. Yeah, that's rare that they do it that way, but yeah, it can show up like that. Page 11, number 5. Yes. Okay, I'm going to jump to the graphing calculator real fast. Please bring your calculator, you guys. Please, please, please bring your calculator. It hurts my heart when you don't have it. Okay, so here's the deal on this one. It says find the real solutions of each equation by graphing. So you put that into your calculator, which is what I have here, and then you hit zoom 6. How many zeros do you see? 1. How many zeros should there be? 3, right? It's negative x to the third power. So if your graph is only showing you 1, what do you suppose is going on?
Messed up.
You have 2 imaginary solutions, right? So your calculator is only going to give you the real solutions, which is why it said find the real solutions by graphing. The only one that you can find here is if you go second trace 5, enter, 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 negative 0.60 is your only real solution. That make sense? Yeah, no, your calculator is not broken. It's just only giving you real solutions. There's imaginary ones too. That is 5 on page 11.
Mine still says 13.
I have a question.
Yeah.
Okay, so on page 13, 21 and 22,
1 second.
how come there's not like a 0?
On page 13.
Or at, okay.
Why isn't there a 0 as an answer?
No.
What number are you looking at?
Looking at both of them to be honest.
Both of what?
21 and 22.
Oh, I'm on the wrong page. What page did you say? 13? Oh, okay. These two. So why isn't there a 0 where?
After x, and why isn't there a 0 after
So here's the thing. Hey, don't start talking. I'm still going. Like for this one, this is 2x cubed plus 0x squared, because there's no x squared term, minus 4x plus, this is like saying 3 times x to the 0 power. But x to the 0 power, anything to the 0 power is 1, right? So you just don't put that 0 in. It's just a constant. No, if there's no like x squared, you put a 0 in for that. But you have your x to the first. That's all you need. If there was this with nothing, like if the 3 wasn't there, then you would put a 0 in there. Okay? What? I just recorded this. Oh, like on the 0 thing? I mean, this is where we did